Alright, so let's look at 10.35 and we're going to look at B. We talked about this in class. So right now we're going to look at the question that says, the synthesis shown here are unlikely to occur as written. What's wrong with each? So we look at B, we see immediately that it's an allylic bromination. Right, we know it's an allylic bromination because you have an alkene, which is here. You have an allylic site here. You have an allylic site here. And you treat this with MbS and carbon tetrachloride. So those reagents with this substrate, that automatically indicates that you're going to have an allylic bromination. So let's look at how this works out. So we go, so here's my alkene, what I started with, and if you look here, and you know the mechanism is a radical chain reaction, so you know that in propagation you're going to get two new radicals. Well, in this case, what you're going to get is a radical here, and then a radical here, both of these being the allylic sites. And so if that's the case, then those allylic radicals, when you see that, you immediately need to be thinking about whether or not it's going to rearrange. And there's no cut and dry formula or way to do it. It's just, you know, if you rearrange it and then you look to see if the product is going to be more stable. So the way, move this here, expand it. So now you see here, right, you see we have a radical here, and then we get the other radical that rearranges. We form this radical here. Both of these form more substituted alkenes as the product. And you can see from here that neither one of these will give you that product that we saw earlier. Right, this would give you a product with bromine here, and then this will give you a product with bromine here, neither of which resemble the product from the previous slide. All right, so the last question, identify the reagents A through C. We're going to omit C because C is an organometallic problem, and we haven't done that yet. We'll start on that next week. But if you'll notice, going from the start material here to A, right, this is a reaction that we're familiar with. You converting an alkene into an alcohol, and notice alkene has two carbons here and here, and so the OH can add to either carbon, but notice it adds to this carbon, and there's a reason for that, right? This set of reagents is going to determine which carbon that OH ends up on. So this would be anti-Markovnikov addition of OH, which we know we use BH3 in the first step, and in the second step we use H2O2. And then after that step, here's our alcohol. Notice we're going from an alcohol to an alcohalide. It's a secondary carbon. Right? So if it's a secondary carbon, remember we got a few methods that we could use for that. We can use, in this case, would have been a secondary alcohol, and we're converting it to a bromide. We could use HBr, or we could use PBr3. Both of those reagents would accomplish the same outcome. The OH will, the hydroxyl group will be converted into a bromine.